Assalamu alaikum. Welcome to lecture 4 of data mining. So today we will be discussing data preprocessing. In the previous lecture, we had talked about exploratory data analysis. We discussed some basic stats and looked at some basic visualizations. The whole idea behind those activities was to get a better understanding of the data and from the data get a better understanding of the process that is generating the data. So today we will start with pre-processing, and as I said last time, pre-processing can have a number of techniques and they can be categorized in a number of ways. So we will follow the categorization that is given in the book by uh, Han and discuss the techniques briefly in each of those categories. So that is the agenda for today. And as you know, we do have a quiz as well today at the end of class around 3:05. So I'll be stopping this session before then. So are there any questions before we get started with the new content? All right. Any questions? All right. So we will start with a brief discussion on data quality. So one of the goals of data preprocessing is to improve the quality of the data. And of course, quality is a abstract term, and it has to be judged. Usually, we can't have one number to quantify the quality of data. So it's a qualitative assessment of the quality of the data. And within data preprocessing, we have various activities or tasks. We have what is known as data cleaning, and then we have data integration. We can then talk about data reduction and then data transformation or normalization and data discretization. So these are the categories that are defined. And within each category, we'll discuss some techniques to implement. The thing that to remember here is that these are categories that are uh, typically defined, but it doesn't mean that you have to apply each of those categories on your particular project. So it will only depend on the need of your project whether you apply a particular technique from a particular category or not. So, how do you measure the data quality? So, usually, as I said, it's a qualitative assessment, and you may have several factors that you need to consider. And some of these qualitative factors are listed here. So, the first factor is accuracy. So, accuracy is basically how close the value that is recorded is to the true value. And you need to make an assessment regarding the accuracy of data in your database. You can do this quantitatively as well. You can have some measures as long as you have some way of quantifying or finding the difference between the value and the true value. So the other factor is completeness. So your data has to be complete. If there are things that are incomplete, missing, uh, then of course the quality would be poor. And generally, completeness uh, is tied with your specific application, your specific task. So if data that is required for your task is not available, then of course your data is incomplete. Of course, it may be complete for some other task. But let's say if you want to do cluster analysis of student data and you don't have a student GPA information or their current uh, total credit enrollment, then that would not give you good results. But if you want to do, let's say, course assignment or course selection by students, and you have data for the enrollment of students in various courses, then that should be fine. So depending on the task, your data might be complete or incomplete. So you have to decide on that. So consistency is another factor that you need to consider. Consistency essentially means that uh, uh, if you have related values in your database, then they should make sense. They should be related. Uh, they can be related by human beings as well as automatic automatic algorithms. So it has to be consistent. So, for example, just to give example, let's say if you have a data, again, let's take the student data at LUMS. So consistency might mean, for example, if you have a GPA column for a student and in some values you have GPA written out of 4, GPA given out of a maximum of 4. In others, let's say the GPA is given out of a maximum of 5. Actually, some universities do use that grading system where the GPA has a maximum value of 5. So in that case, it will be inconsistent. So everything has to follow one set of rules in your data set. So timeliness, of course, your data has to be current and it should be relevant to your task again. So let's say if you are trying to do stock analysis, let's say Pakistan Stock Exchange data, if you want to do analysis for the last 2, 3 years, but you don't have data for the previous 10 years, but you have data from the 1990s. So that would be irrelevant. You need current data to do predictions that are current. You can't use 1990s data to make predictions for today. So timeliness is important as well. So believability is essentially how how trustable the data is. So this is again a qualitative assessment based on what you see from the data, based on how the data has been collected. So 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 this is basically believability. For example, if there's an outlier, let's say there's a value that is written as 125 for age, obviously that is difficult to believe. Someone has an age of 125. So finally, interpretability. So the data should be in a format in a way that is easy to understand by humans. So if the data is extremely complicated, uh, so obviously people won't have a trust in using that data. They won't be able to understand what is in the data. So it has to be interpretable. You should be able to derive meaningful uh, interpretations, reasonings from the data without processing it. So the numbers should make sense. The columns and the rows should make sense. So these are some of the factors that you need to consider to assess the quality of the data. For some of these factors, there might be some quantitative measures. For example, regarding completeness, you can, for example, you can, given a database, you can count the number of missing values. So percentage of missing value in the data set. So you can define measures like this. So if like 10% of data is missing, if uh, 50% of data is missing and so on. So you can even count, let's say sometimes uh, you will have some labels given to the values, let's say NA, not applicable or not available. Sometimes people would write null there. So you can't count the occurrences of these values as well. So this means that that data is missing or not available and so on. Okay, so you can use some quantitative measures as well, but overall quality is has to be assessed qualitatively. So the major task, again, data cleaning, data integration, data reduction, transformation, and normalization, and then discretization. So let's start with data cleaning. So data cleaning essentially involves three things. One is the data has missing values or is incomplete. So that's one thing. The other thing is data is noisy. So again, this is an aspect of cleanliness. And finally, data is inconsistent, meaning that you can see inconsistencies in data. Maybe one value has been one, let's say you have different units for recording a particular uh, value. So for example, weight sometimes recorded in kg, weight sometimes recorded in pounds. So inconsistencies like these are also factors that would lead to uh, uh, bad data, unclean data. So essentially, cleanliness tries to fix these problems or look at these problems. The first one, as I said, is missing values or missing information or missing data. The second is noisy data, and the third is inconsistent data. So another example of inconsistency, let's say you have two columns, one is birth date, the other is date of birth. So both of them would be inconsistent. So in that particular case, of course, you will prefer the date of birth over the age. So usually age would be recorded on a particular timestamp, while the date of birth is a fixed value characteristic of that particular individual. Okay. So some other examples are also given on this slide. So you can look at them as well. So starting with missing data. So why do we have missing data? There could be various reasons, and some of these reasons are also the reasons for other problems in cleanliness. So data may be missing because of some human error, because of some machine error. It could be data entry error, data transmission error. Uh, Maybe the data is not available at the time of entry. Maybe at the time of entry, data was not found to be important, but later on it was found to be important. So things like that would always lead to missing values. So sometimes you often have some automatic checks in your database. Uh, let's say you have some SQL code that checks inconsistency in the data. So if there's an inconsistency in data, maybe that check will remove both values. So that would also lead to missing values. So what should we do if we have lots of missing values in your data? So let's look at some quick solutions to this. So basically handling. So first of all, you can have missing values in attributes, which is columns, right? And you can have missing values in observations for a particular, which means rows. So if you look at a particular row in your database, there may be multiple missing values. If you look at a particular column in your uh, database, tabular database, you might have many missing values. So sometimes we will quantify the missing values per row and per column, or for rows and for columns separately. So for example, if a particular attribute has more than, let's say, 20% values missing for an attribute, so you can consider, 20 is just an arbitrary number. This is something that you will have to decide. So if you feel that a significant percentage of attribute values are missing, then you might have to drop that attribute entirely. Okay? Do not use that in your analysis because a lot of values are missing. The same would apply for rows. If one observation, let's say एक स्टूडेंट का रिकॉर्ड है, उस स्टूडेंट के रिकॉर्ड का सिर्फ नाम मिल रहा है आपको, बाकी कुछ भी नहीं है, एज भी नहीं है, उसका जीपीए भी नहीं है, उसका कोर्स एनरोलमेंट भी नहीं है, so lots of things are missing, so you will just drop that row. So again, you will have to decide either by applying a check on percentage missing values, and then maybe finally a human looks at those values, those rows and those columns, decide whether to keep them or not. Okay? So for scenarios where the missing percentage is low, then you would probably have to infer the missing values. So, or fill in the missing values. Okay? Uh, so obviously, uh, you can have simple to very sophisticated techniques for filling in missing values. In data preprocessing, while we are doing preprocessing, we'll prefer simpler techniques because this is not the stage where we want to build complex models. This is where we want to do quick fixes so that we can later on and go on and apply our more advanced techniques on the data. So what do we typically do? So one solution is, let's say, if you have missing values in a column, in an attribute, you can fill in by mean. What is the mean? Is a measure of the central tendency. Of course, if it is quantitative, if it is numeric, then you can compute the mean. If it is something else, maybe you can fill in with the median. If it is purely nominal, then you can fill in by the mode. So this is for the case when the number of missing values is relatively low. Okay? So just to take a quick example, let's say uh, so continuous numbers की आप बात करें तो let's say ages आपको दी हुई हैं, ages let's say student के ages हैं 20 है, 21 है, question mark means that is missing 21 है, 22 है, ठीक है? So ठीक है? So four values are available, one value is missing. So you can fill in that missing value by taking the average or the mean of the remaining values. So that is just an estimate. It's not the actual value, it's an estimate so that you can fill in with something that is reasonably meaningful. ठीक है ना? तो basically simply 20 plus 21 plus 21 plus 22 divided by 4. So you may fill it with this value. So 21 would be the value that you will fill in into that value. ठीक है? So इसी तरह कोई आपके पास categorical attribute है तो you can use the mode. For example, colors की values हैं R and B and there is one question mark. So the mode here is R, so you will maybe question mark को आप R set कर देंगे. ठीक है? So that is one way of filling it. Of course, this is not the true value. You did not observe it. It's just trying to fill in the values for the purpose of maybe ensuring that your algorithms do not fail. Remember, there are some algorithms later on in data mining that would not work if your data has missing values, or they if you in the missing value means they are just blank. And if you fill those values by some lesser placeholder, then they might give you misleading results. So that's why we would like to fill them with some reasonable values. The other technique is fill in by category, mean, median, mode. So instead of a mean for the entire column or median for the entire column, you can define semantically meaningful categories and define the mean or median or mode for each category. And then if a one observation belongs to a particular category, you use that mean for filling it. So again, just take the example of age. So let's say हमारी categories students की हम बना सकते हैं कि there is freshman, sophomore, junior and senior. So we'll find the mean of all the juniors. Let's say mean एज लेट्स से हमने निकाली तो 20.5 थी, या जूनियर की थोड़ी सी कम होगी, हाँ जूनियर की ठीक है 20.5 ठीक है. So if there is a missing value for junior, then we will fill that with 20.5. But let's say if the senior की is 21.5 let's say, तो जो सीनियर की कोई कॉलम किसी का एज मिसिंग है तो उसको हम 21.5 से फिल कर देंगे. So we look at the category of the observation, and based on the mean for that category, we use that mean to fill in the value. So this estimate would be somewhat better than the previous case where we use a blanket or a global mean to fill missing values. Okay? So, and then of course you may have some more sophisticated techniques which are less common, especially during the data pre-processing step. So, for example, you can build a regression model to predict the missing value. Of course, if this is a continuous value, if it is a categorical value, you can build a classification model like a decision tree or a support vector machine or a neural network. And of course, these are based on models. You can also use some clustering approach. So clustering का मतलब ये है कि again you allow the data to be grouped automatically, और फिर हर group का mean आप ले लें, वो mean फिर use करें if a particular observation falls within a group. Remember in the previous example जो मैंने ऊपर बताया था fill in by the category, उसमें कैटेगरी हमने खुद ही बताई थी कि जूनियर है, ये सीनियर है, ये फ्रेशमैन है, सो ऑन, या वो कैटेगरीज अवेलेबल थी हमारे डेटा में. But let's say categories अवेलेबल नहीं है, तो you can ask the clustering algorithm to form the groups automatically. अब कोई ऑब्जर्वेशन एक ग्रुप के अंदर आ रही है तो फिर उसका मीन उस ऑब्जर्वेशन में डालेंगे, किसी और ग्रुप में आ रही है तो उसका मीन उस ग्रुप में डालेंगे. So this is the idea of the clustering approach. But as I said, these are less commonly used. हम simply जो पहली तीन टेक्निक्स है, एक तो इग्नोर कर दें इसको, especially when the missing values are high, और दूसरा fill in by the mean median mode, and then third fill in by the mean median mode of categories. ठीक है? In each of these three cases, all of these cases, your data is changing. In a way, you're transforming the data. You are biasing the data. So you have to be aware of that. So for example, आपके पास बहुत सारी missing values हैं और आपने किसी technique से fill कर दिया है, then of course your data is biased by that technique that you're using to fill those values. So you need to be aware of these issues while you are doing this filling in the missing values. Next is noisy data. Noise, what is noise? Noise is basically random variation in the values. Uh, and this again arises due to various reasons. It could be human error, it could be machine error, it could be transmission error. Uh, and it is noise because it's kind of random. You can't really predict a priori whether the error will be on one side or the other side. ठीक है ना? Uh, so we typically distinguish between noise and outlier. Outlier is a true value of the process, even though it is significantly different from the rest of the observation. Noise is not a true value, it's a artifact, primarily because of transmission errors or machine errors or human errors. ठीक है? सो फॉर एग्जांपल जस्ट से हमने ह्यूमन एंट्री की बात कर रहे हैं, तो किसी ने एज 25 टाइप करनी थी, तो गलती से उसने टाइप 2 टाइप कर दिया, 225 आ गया। अब ये दिस इज अ रैंडम एरर इन द सेंस दैट कि 225 लिखा तो मे बी किसी और वजह से वो 125 भी लिख सकता था, या कोई और वैल्यू भी लिख सकता था। ठीक है? सो सच एरर्स आर टिपिकली called noise. They are not true values of the process. And they may be significantly different from the rest of the values, or they may be within those values. So for example, ये भी हो सकता है कि let's say आपकी बड़ी हाई एक्यूरेसी का आपने रिकॉर्डिंग्स करनी है, let's say of pressure for example. So pressure, let's say आपने पास्कल में रिकॉर्ड करना है 210, let's say 0.57, ठीक है? बट जब वो टाइप, अगेन टाइपिंग की मैं बात कर रहा हूँ, ऑफ कोर्स एरर्स, नॉइज कैन अराइज फ्रॉम ट्रांसमिशन एरर्स एज वेल, तो आपको डेटा करप्ट हो जाए, तो 210.87 इसने कर दिया। ठीक है? इन दिस केस द डिफरेंस इज नॉट वेरी लार्ज, इट्स नॉट लाइक एन आउटलायर बट स्टिल नॉइज, रैंडम वेरिएशन है। ठीक है? सो हाउ डू यू डिस्टिंग्विश बिटवीन नॉइज एंड आउटलायर? जनरली इट्स काइंड ऑफ डिफिकल्ट, यू कांट डू इट। टिपिकली हम विजुलाइज करते हैं, ट्राई टू अंडरस्टैंड इट। नॉइज टिपिकली होती है कि हर वैल्यू पे आपको वेरिएशन नजर आएगी। आउटलायर्स आर यूजुअली फार अवे फ्रॉम द rest of the values. So you usually visualize the data to find out whether it is noisy or not. अच्छा, तो जब नॉइज है तो उसको हम क्या करेंगे? Maybe we just leave it as it is. But if you want to fix few things, then what we typically do is do some simple smoothing, smooth the noise. So smoothing again is transforming the data. You will be applying some basic models to estimate uh, the values and then use those estimates to fill in the noisy values or to correct the noisy values. तो स्मूथिंग में सिंपल टेक्निक्स हम टिपिकली यूज करेंगे. द मोस्ट कॉमन दैट इज यूज्ड इन द प्री प्रोसेसिंग स्टेप इज व्हाट इज नोन एज बिनिंग. ठीक है? And binning can be used for numeric as well as ordinal categorical data. It can be used for nominal also. So, okay. So, usually, most commonly it is used for numeric data. So, binning, let's take a quick example. क्या होती है binning? Very easy actually. uh, so, binning में, let's again take the example of age and ठीक है. So, let's say 20, 21, and I sort the values. ठीक है? You have to sort the values. Um, okay, yeah. So 21, 22, 25, 27, 30. Although they don't seem to be too noisy, but let's to just explain the process. ठीक है? Oops. List में देखा सकते हैं. All right. So any questions? ठीक है. Okay. So there are again two sub techniques in binning. One is based on equi width and the other is equi depth. So in equi width, we define a bin of fixed interval length. So in this particular case, let's say you have data ranging from 20 to 30 and you define a fixed interval length. Uh, so you can say you have 20 to 30 वो आप let's say uh, so for example you can define a 20 to 22 एक bin हो गया बड़ा ही कर लेते हैं let me say 24 कर लें 24 both values are inclusive let's say 24 to 28 oops just a second 25 कर लें इधर 27 and then we have 28 to let's say 31 ठीक है so we have defined equi-width intervals so within each interval you have the values now so between 20 and 23 so within the first bin we'll have 21 sorry 20 21 21 and 22 पहले bin में ये चार आ जाएंगे दूसरा है between 24 and 27 उसमें आपके पास दूसरा जो bin होगा उसमें आपके पास आएगी एक 25 एंड एक 27 एंड थर्ड तीसरे bin में सिर्फ 30 आएगा so now you have three bins and you have the values in those bins so now you can use uh, again the mean the central tendency within each bin to replace all the values with that bin with that value so kind of smoothing within bins so जो पहला bin था उसमें चार values हैं उसका let's say mean हम लेंगे तो basically 20 21 plus 21 plus 22 divided by 4 so mean is 21 so if you want to smooth by the mean the पहली bin में चारों values पर आप 21 कर देंगे ठीक है so this is the first bin so you have smoothed the variations within the bin the second में आपके पास 25 and 27 उसका mean 26 है 26 हो जाएंगे दोनों और third bin of course just one value उसका mean 30 है so this would be kind of the smooth value for this so you can use the median if you have ordinal data you can also use median if it is numeric as well median generally is a better measure of the central tendency ठीक है इसमें आप फर्दर वेरिएशंस कर सकते हैं समटाइम्स दे जो एजेस हैं उनकी वैल्यूज आप ओरिजिनल रख लेते हैं मीन सिर्फ बीच में रख लेंगे so you can do variations like that people have done that in the literature or you can use more sophisticated techniques so you can use like a moving average approach moving average actually more appropriate for time series data ये later on हम discuss करेंगे time series में so you can use a moving average of course ये ऊपर हमने equi width किया था you can also do equi depth इक्वी डेप्थ में क्या होगा, यू डिफाइन बिन्स दैट कंटेन ए फिक्स नंबर ऑफ ऑब्जर्वेशंस, तो डेप्थ सेम है हर बिन की। सो लेट्स से आपने डेप्थ 3 रखी है, तो यू हैव ए बिन, द फर्स्ट बिन विद 3 वैल्यूज। सो पहले में 20 आएगा, 21 आएगा और 21 आएगा, पहला बिन हो गया खत्म। तो उसके बाद 22, 25, 27, तीसरा बिन खत्म हो, दूसरा बिन खत्म हो गया, और तीसरे बिन में ऑफ कोर्स सिर्फ एक है, 30। Now after doing this binning, you apply the same smoothing by the mean or median. ठीक है? All right. So this was noise. Of course, noise removal के लिए आप more sophisticated models भी use कर सकते हैं, जिसमें regression फिर आ जाएगा. Regression modeling can be used, but of course, this would be more appropriate if your data does follow some regression or parametric model. तो but generally, as I said, प्री प्रोसेसिंग में हम इतने सोफिस्टिकेटेड मॉडल्स अप्लाई नहीं करते। सो ऑफ कोर्स रिग्रेशन इज पैरामीट्रिक, क्लस्टरिंग भी अप्लाई कर सकते हैं, विच इज बेसिकली नॉन पैरामीट्रिक, जिस तरह पिछली टेक्निक में भी किया था, ये दोनों यहाँ भी हो सकते हैं, बट नॉट कॉमनली यूज्ड। ओके, दिस वाज द सेकंड thing in cleaning. The third thing was inconsistency. Inconsistent data basically means that you can, so the data is recorded in a way that makes it so it conflicts with one another. So the example that I gave you कि एक attribute age है और एक attribute date of birth है, both of those two attributes conflict with each other. आप age use करेंगे तो current time में वो सही नहीं आ रही given the date of birth. So in this particular case, the solution is relatively easy. आप date of birth maintain कर लेंगे. In other cases, there could be issues of uh, recording data in multiple units. Uh, so, so centimeters, millimeters, meters, inches, feet, लेंथ आपने फीट में कहीं लिख दी, कहीं लेंथ आपने मीटर्स में लिख दी. तो unless you have metadata associated with that recording, you wouldn't be able to easily determine कौन सी वैल्यू फीट में है, कौन सी मीटर्स में है. फॉर एग्जांपल लेट्स से मैं कोई लेंथ की बात करता हूँ, प्लॉट की एक लेंथ है, तो लेट्स से एक जगह किसी ने 100 फीट लिखा हुआ है, अजम्पशन उसकी थी वहाँ फीट थी, बट एक और जगह पे एक और 100 लिखा हुआ है, बट यहाँ उसकी अजम्पशन थी कि ये मीटर है. सो इन जनरल यू वोंट बी एबल टू फिगर आउट कि ये दोनों वैल्यूज गलत हैं, अनलेस यू हैव ए क्लू कि ये डिफरेंट यूनिट्स में लिखी गई हैं, या आप कोई प्रोसेसिंग जब कर रहे हैं लुकिंग एट द अदर एट्रीब्यूट्स वैल्यूज, यू फाउंड आउट दैट दिस डजंट मेक सेंस, ये 100 फीट नहीं हो सकता, ये कोई और यूनिट होगा. ठीक है? So it's not, there isn't one real solution to this. So it's more of exploratory analysis of your data, trying to figure out if there is inconsistencies. One thing that you can do is if your data set has a well-defined metadata. Metadata, I hope all you know what that is. या इसको डेटा डिक्शनरी भी कहते हैं. डेटाबेसेस में आपने पढ़ा होगा. तो जो भी स्कीमा बनता है, उस स्कीमा की डिटेल्ड इंफॉर्मेशन भी लिखी जाती है, कि लेट्स से एज है, आप बताते हैं कि एज के डोमेन क्या है, एज वुड रेंज बिटवीन 10 एंड 80 या 10 एंड 50 एंड सो ऑन. उसके लेट्स से कोई वेट की बात हो रही है, तो वेट की भी आप रेंज लिखेंगे, फिर उसमें उसकी डिस्क्रिप्शन पहले लिखेंगे, वेट फॉर व्हाट, एंड देन उसकी रेंज लिखेंगे, फिर इसका यूनिट लिखेंगे. सो इफ सच इंफॉर्मेशन इज अवेलेबल, यू कैन यूज दैट टू फाइंड आउट इनकंसिस्टेंसीज एज वेल. ठीक है? But in general, it's not an easy task. It's a dirty task, मुश्किल task है. Exploratory data analysis करना पड़ता है आपको, देखना पड़ता है. You need to go back to the business people and ask them कि ये value looks suspicious to me. Can you verify it and so on. तो इस तरह की चीजें आपको करनी पड़ती हैं. There isn't any automatic, truly automatic solution here. ठीक है. All right. So now let's move on to the next major category. So we talked about data cleaning. The next major category is data integration. ठीक है. So as the name suggests here, we are combining data from multiple sources. ठीक है. And so the sources could be databases, they could be information from the internet, they could be reports that are published by uh, third party organizations, they could be files, even paper files as well that you digitize and so on. So lots of information coming together, you want to integrate them. Uh, अब इसमें जो issues आते हैं इसमें typically दो main issues आते हैं which you need to be careful about. One is schema uh, integration and the other is redundancy. ठीक है. So what is schema integration? So schema is essentially the format in which you save your data. ठीक है ना. Databases में आपने schema पढ़ा होगा. So in the case of the standard tabular data set that we introduce in this course, schema would be कि वो बताएगा कि आपके हर एक कॉलम का एट्रीब्यूट क्या है और उसकी बेसिक इंफॉर्मेशन क्या है और या उसकी डोमेन क्या हो सकती है. इसी तरह हर एक रो में क्या चीज़ रिकॉर्ड हो रही है. इज इट फॉर एग्जांपल स्टूडेंट है तो स्टूडेंट की इंफॉर्मेशन होगी या कोई और चीज़ है तो उसकी इंफॉर्मेशन होगी. तो बेसिक इंफॉर्मेशन अबाउट योर डेटा सेट. जब आपके पास डेटा मल्टीपल सोर्सेज से आ रहा होता है तो देर इज एन इश्यू ऑफ इंटीग्रेटिंग द स्कीमा. तो जस्ट टू टेक अ सिंपल एग्जांपल, लेट्स से आपके पास कंपनी है, आपके पास सेल्स का डेटाबेस है एक है और इसी तरह आपके पास एक मार्केटिंग का डेटाबेस भी है. सो सेल्स का डेटाबेस क्या होता है? जो कस्टमर जो आपकी चीज़ें खरीदते हैं. और मार्केटिंग क्या है? जो लोगों को जिन लोगों को आप रीच आउट करते हैं फॉर लेट्स से न्यू प्रोडक्ट्स एंड प्रमोशंस एंड मार्केटिंग एंड सो ऑन. ठीक है. अब दोनों डेटाबेसेस में पीपल की इंफॉर्मेशन है. ठीक है. सो मे बी इन द सेल्स डेटाबेस, let's talk about the column headings only. Uh, so एक तो सिंपल इशू ये हो सकता है कि द नेमिंग कन्वेंशन माइट बी डिफरेंट. सो फॉर एग्जांपल इट माइट बी द सेम थिंग बट कॉलम की हेडिंग एक डेटाबेस में कुछ हो रहा है, दूसरे डेटाबेस में कुछ हो रहा है. तो यू कैन सिंपली टेक द इशू ऑफ लेट्स से एक डेटाबेस में लेट्स से नेम यूज किया हुआ है फॉर द फुल नेम ऑफ द कस्टमर, लेट्स से इन द सेल्स डेटाबेस. दूसरे डेटाबेस में लेट्स से सिंपली हमने एक कॉलम डिफाइन किया हुआ लास्ट नेम का, फर्स्ट नेम हमने शायद रिकॉर्ड ही नहीं किया लेट्स से. सो नाउ द इशू ऑलवेज अराइजेज इज ऑफ कोर्स जब आप सीधा उनके नामों को देखेंगे द नेम्स आर डिफरेंट बट सेमेंटिकली यू नीड टू नो कि दीज टू आर रिलेटेड और इनको आपको इंटीग्रेट या मर्ज करना पड़ेगा. बिकॉज जो फर्स्ट नेम है उसमें पूरा नाम होगा, लास्ट नेम भी इंक्लूडेड होगा मोस्ट लाइकली, और दूसरे डेटाबेस में सिर्फ लास्ट नेम लिखा हुआ है. सो यू विल हैव टू check कि वो last name पहले वाले में आ रहा है, and then you see कि whether these are the same person or not. If it's the same person, then you merge those data sets, that person. Otherwise, merge नहीं करेंगे. ठीक है, but इस तरह के जो potential issues हैं, you will have to figure out by looking at the data set closely. Automatically again ये नहीं हो सकता इतनी आसानी से. सो इसी तरह फॉर एग्जांपल जो यूनिट्स की हमने बात की थी यहाँ भी आ सकती है. लेट्स से एक डेटाबेस में फॉर एग्जांपल हाइट हम कस्टमर या बंदे की लिख रहे हैं, एक में फीटों में लिखा हुआ है, दूसरे में सेंटीमीटर में लिखा हुआ है. ठीक है, सो अगेन यू नीड टू मेक श्योर के दे हैव टू बी कन्वर्टेड टू द सेम यूनिट बिफोर दे आर मर्ज्ड और इंटीग्रेटेड. ठीक है. So in most of these cases, you will have to look at the data as well as the data dictionary जो पहले मैंने बात बताई थी. If it exists, उनको study करना पड़ेगा and then see के whether these two columns are the same thing or not. And then maybe select one uh, naming scheme for the new database, that is the integration of the two. ठीक है. So integration में of course inconsistency के issues बेशुमार आते हैं. So again the sales और मार्केटिंग की बात करें, लेट्स से आपको पता चल गया कि एक ही कस्टमर है, एक कोई बंदा है, लेट्स से आसिम करीम इज द सेल्स डेटाबेस में भी आसिम करीम है और मार्केटिंग में भी यही है. बट जब आप दोनों डेटाबेस का उनका एड्रेस देखेंगे, एक में एड्रेस कुछ हो रहा है, दूसरे में कुछ हो रहा है. एक में लेट्स से लम्स लिखा हुआ है, दूसरे में लेट्स से बेदिया रोड लिखा हुआ है. तो विच वन इज करेक्ट? तो ये इनकन्सिस्टेंसी अराइज हो जाएगी व्हेन यू डू द मर्जिंग. तो दिस इज समथिंग दैट यू हैव टू बी केयरफुल अबाउट कि कौन सा रिटेन करेंगे. सो वन सिंपल वे वुड बी के आप देखेंगे कौन सा डेटाबेस में वो रीसेंट एंट्री है. सो इफ देर इज अ टाइम स्टैम्प विद द एंट्री, वो आप चूज कर लेंगे. फॉर एग्जांपल लम्स वाली एंट्री लेट्स से मोर रीसेंट है, इट मींस दैट दैट इज द बेटर एड्रेस एज कंपेयर टू द अदर वन. ठीक है. ओके, सो दैट वाज अबाउट स्कीमा इंटीग्रेशन. सो अगेन लॉट्स ऑफ इश्यूज हेयर. आपको कॉलम नेम्स को मैच करना पड़ेगा, कॉलम्स के अंदर जो वैल्यूज़ हैं वो भी कई दफ़ा आपको मैच करनी पड़ती हैं, फिर इनकन्सिस्टेंसीज आती हैं वो आपको देखनी पड़ती हैं, एंड सो ऑन. द अदर इशू दैट आई मेंशन्ड हियर, क्या, yeah, we still have time. Other issue is redundancy. So it might be possible कि जब आप merge करें, integrate करें, you get the same value twice or same attribute twice, even though उनके नाम different थे, आपको पता नहीं था. So जैसे पीछे schema integration से आपको figure out नहीं हुआ. ठीक है. uh, and there may be other uh, problems as well. तो redundancy detection किस तरह कर सकते हैं आप? Let's say आपके पास दो columns आ गए, एक x है column और एक y है. I'm just purposely giving them names that are not meaningful. X और Y दो columns आए from two different databases and you know that they belong to the same entity, so आपने वो add कर दिए अपने database में. But जब आपने इसकी correlation analysis किया, so you found that the correlation between X and Y, let's say both of them numeric, is very high. Let's say 0.95 या इससे भी ज़्यादा 96 कर लें. ठीक है. So correlation, as you know, ranges from -1 to +1. ठीक है. So this means that both of these values are strongly correlated. मतलब ये है कि एक की value है तो दूसरी की भी वही value है. Of course, absolute values might be different, but the relationship is almost the same. So then you need to investigate such pairs of attributes more closely. It may means that they are the same uh, concept, but they may be written in different ways. Maybe एक का यूनिट पाउंड में था, दूसरा यूनिट केजी में था, या कुछ और इस तरह का रिलेटेड इशू है. ठीक है. The same thing would apply if the correlation is strong but on the negative side. Also, if two attributes are highly correlated, like X and Y in this case, to most analysis would pick only one, oftentimes automatically. तो आपको दोनों रखने की भी जरूरत नहीं है. दूसरा redundant है. आप एक से ही काम चला सकते हैं. आपका analysis would not be affected much if you drop one. ठीक है. One attribute. Of course, correlation analysis हमने पहले पढ़ लिया है. If both x and y are categorical, you would probably be using chi-square. ठीक है. If both of them are one is categorical, one is numeric, you can use AUC or you can use mutual information. ठीक है. Uh, and of course, if both of them are numeric, you can use correlation or covariance. ठीक है. And if the value is high, then they are potentially redundant. So in most of these cases, usually purely automatic decision नहीं कर सकते आप. So it's basically semi-automatic. So you run some algorithm like correlation analysis, find out pairs of attributes that have very strong correlations either on the positive or negative side. Let's say आपको threshold रख लेते हैं 0.9 या 0.8, and then let the finally and output those pairs of attributes to the data scientist, data engineer, और वो फिर फाइनल डिसाइड करता है कि इनमें मसला क्या है, इनको दोनों को रखना है कि एक को रखना है, सो ऑन. ठीक है. रिडंडेंट है कि नहीं है. राइट. So these are the two main issues and some resolutions in data integration. So one is schema integration identification, and the second is redundancy identification or detection. Okay. All right. Uh, so we still have about 10 minutes. So let's move on to the other category, the third category, which is called data reduction. Okay. So, uh, so as the name suggests, in data reduction, we want to reduce the size of the data. ठीक है. अब reduction हमारा basically वो tabular format database है. Reduction can be done in the number of columns or features. Reduction can be done in the number of rows. ठीक है. So both are possible, and the number of columns uh, are features. ठीक है. So feature reduction में हमारे पास typically दो techniques होती हैं. One is feature selection. ठीक है. And the other is called feature extraction. तो समटाइम्स इन दोनों को इकट्ठा करके डायमेंशनैलिटी रिडक्शन भी हम कह देते हैं. ठीक है. डायमेंशनैलिटी रिडक्शन. ठीक है. सो फीचर सिलेक्शन, फीचर एक्सट्रैक्शन. सो यू कैन call both of these dimensionality reduction, although ये यूनिवर्सल नहीं है. although dimensionality reduction ना ज़्यादा फीचर एक्सट्रैक्शन की तरफ जाता है, बट sometimes used loosely. different terms ये loosely use होते हैं. I personally prefer feature selection and feature extraction. ठीक है. So sometimes people say dimensionality reduction is same as feature extraction. ठीक है. All right. So what is the idea here? Let's start about feature uh, or in general features. So what are features? Features are the number of attributes or variables or you can say attributes that you are using in your analysis. we can also call them as dimensions. So in general, and this is particularly true for machine learning, if you have too many dimensions, uh, your data would become very sparse and you wouldn't be able to learn much. Okay? And this is typically called the curse of dimensionality. So usually one reason to reduce the number of dimensions or features is to avoid the curse of uh, dimensionality. Okay? Of course, the other reasons could be you want to retain the most important information, you want to increase the efficiency of your algorithms, you want to remove noise. So these are other reasons why you would like to reduce the number of features or dimensions in your analysis. So let's quickly start with feature selection. So let's say if your data set originally has M features. So from these M features, you want to set K, which is less than M features. So originally you have M features, you want to select K features. ठीक है? From those M features. Selection हो रही है. So let's say आपके पास attributes तीन है, A है और एक B है और एक C है. In this case, M is equal to 3. Let's say आपने K is equal to 2 करना है, तो कौन से दो options लेंगे आप? A, एक B है, A, C है, and B, C. तीन options आपके पास. ठीक है ना? In general, for any M and K, ये कितने possible options बनेंगे आपके पास? So we are finding combinations of size K from a total number of options that are M. So मेरे ख्याल से ये combinatorics वाले बेहतर बताएंगे. It should be M choose K, right? वो जो parentheses बड़े से होते हैं उसके ऊपर M लिखा होता है, नीचे K होता है, right? This many options आपके पास होंगे. So which would be typically very large if K is small and M is large. ठीक है? Actually, it could be the other way. It would generally be large if M is large. Okay. So, so in this particular case, ऊपर वाले में हमारे पास 3 और 2 थे, तो you had 3 options: AB, AC और BC. So, but usually M for most real-world data sets is in the hundreds. So selecting combinations from hundreds of features is not going to be easy. So that's one thing. There are lots of features there. The second question to think about is how would you decide between those options? Let's say you have somehow fixed K मेरे पास एक in the case of example जो बताइए कि 2 आपने ही लेना है. ठीक है? How do you decide which two combination is uh, most appropriate for you? तो उसके लिए usually we will need some intrinsic or extrinsic evaluation measure. So intrinsic or extrinsic evaluation to decide best feature set. ठीक है? So you need to have some measure by which you can quantify the goodness of a particular feature set. So let's first quickly talk about the second one, and I think we are running out of time. Extrinsic की बात करते हैं. तो let's say आपका eventual goal है classification है, और classification में eventual goal उस data set को classification में use करना है. Classification का measure क्या है? Accuracy है. ठीक है। सो व्हाट यू वुड डू इज कि आप मल्टीपल क्लासीफायर्स बनाएंगे, एक दफ़ा ए बी के साथ चलाएंगे, एक दफ़ा ए सी के साथ चलाएंगे, और एक दफ़ा बी सी के साथ चलाएंगे। जिसके साथ बेस्ट रिजल्ट आता है वो रिटेन कर लेंगे आप। ठीक है। ऑफ कोर्स हेयर अगेन आपको सारी ऑप्शंस देखनी पड़ेंगी, बट नाउ यू डू हैव ए मेजर टू क्वांटिफाई विच वन इज बेस्ट। लेट्स से इसमें जो भी बेहतर आता है, लेट्स से बी एंड सी आता है, इट गिव्स यू बेस्ट एक्यूरेसी, यू रिटेन दैट फीचर सेट। ठीक है। सो बट हेयर अगेन वो वाला इशू अभी भी है कि आपने सारी कॉम्बिनेशंस देखनी है। तो उसको अवॉइड करना है तो देन यू हैव टू यूज अ ग्रीडी अप्रोच। उसमें ये होगा कि बेस्ट फर्स्ट, देन द नेक्स्ट बेस्ट, देन द नेक्स्ट बेस्ट। So you choose, let's say, the first single attribute that gives you the best accuracy. Let's say it was B. अब इसके बाद आपने next best attribute देखना है जो add मैं इसके साथ करूँ so that it gives you the best accuracy. Let's say it was C. And if you are stopping at 2, that's where you stop. So this you can use one by one greedy, or you can use a brute force all combinations, but you still need an extrinsic measure to evaluate them. ठीक है। सो ये इस तरह यू कैन डू फीचर सिलेक्शन। So I think I will stop here. Are there any questions? Any questions? अच्छा, looks like कि आज सारे लोग क्लासरूम में बैठे हुए हैं, so Zoom के साथ कनेक्ट तो कम हुए हुए हैं। But if you have any question while in the class, you can always ask. जिसके पास अभी Zoom connected है, तो उसके पास जाके आप क्वेश्चन पूछ सकते हैं।